Hello my scholars, welcome to my school channel. My name is Emmanuel and in today's video we'll be tackling JAMB CBT past question for chemistry in the year 2004. Please don't go anywhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. In today's video, we'll be tackling question number 26 to question number 50. Now let's get down to question number 26. We have a chemical reaction here. This is carbon monoxide reacting with 1 mole of oxygen to give us 2 moles of carbon dioxide. So given that the enthalpy change of CO, that is the product, is negative 110.4 kilojoules per mole, and delta H, that's the enthalpy change for CO2, that's the product, is negative 393.0 kilojoules per mole. So the energy change for the reaction above is what? Now we are going to the board. I'm going to solve it first the normal way we should, okay, then we'll look at the other way around. So let's move to the board and let's see what happens. We have, okay, I will just have 2 CO, of course that's gaseous, reacting with 1 mole of oxygen to give us 2 moles of CO2. Of course, that's also gaseous. They are all in gaseous state. Okay, so the enthalpy change actually is supposed to be for the enthalpy change of product, okay, minus enthalpy change for the reactant. Okay, so in some cases, in fact, I would just like to have it this way: summation of, because it's possible for us to have more than 1 product. Okay, though in this case we have just 1. Then in this case we have 2 of the reactants on that side. Change in what? In reactants will give us that. And already from the question we're given that delta H, okay, for CO was given to be negative 110.4 kilojoules per mole. Yeah, and then we're giving that of CO2, of course that's the product, to be negative 393.0 kilojoules per mole. Okay, we're giving that. So if we are to solve this question, now the product here is CO2, so I'm going to write this to be delta H is equal to delta H of product, which is CO2, minus, but okay, minus, we have in the bracket now, because we have 2 reactants here, so we have delta H for CO plus delta H also for what? For oxygen, O2. Okay, so we have this on this side. So whatever we solve here, but if you look at the equation, we have 2 moles of CO here, okay, and then we have 2 moles of what? CO2 here. So that is going to affect this. So if we have 2 moles here, this should be 2 moles of CO. This is CO, so we have times 2 here, and then we have these 2 moles for CO2. We are going to have times 2 here. So this is supposed to be 2, okay, times change in it, or in enthalpy of CO2 is actually given to be negative 393. Okay, then we have minus, then we have 2 times the heat of enthalpy, change of enthalpy of this is negative 110.4, then plus. Now the enthalpy change of oxygen is actually 0. The reason being that the standard enthalpy formation, okay, for molecular oxygen is actually 0, because this is the most stable, form of what? Of oxygen. So it's usually at 0. So we have this to be 0. So that will be 2 times this is going to be give us negative. That is 6. 2 times that's 18. 1 6 plus 1 7. So negative minus that. Then we have minus. We have that's minus 2 times this. That's 220.8. Okay, that's what we have. So this will be negative 786. Negative cancel negative, multiply that, we have that, then plus 220.8. So by the time you solve this, we'll be having negative 5, let's see, 786 minus 220.8. Okay, that's 2, that's 5, that's 8 minus 2, that's 6, that's 5. So 565.2 kilojoules per mole. Okay, this is what we should have as the what? Enthalpy change for that formation, the energy change for that. 5 minus 565.2. Okay, but if you look at the options we have, all the options we have no option like this there. Okay, well, that's what JAMB gave us. So if we are to work with this, well, maybe someone could say the closest answer we have is negative 503.7. But for me, that is too range. The range is too far apart. 565 and 5003 are too far apart. So instead of that, if you solve it the other way, like I was saying earlier on, this is the normal way, the right way to solve this, because we have these two that we have here, will definitely is going to affect this reactant here that we have here. So the number of mole is saying 2 mole of this react with 1 mole of this to give 2. So it must have effect in the energy. Number of moles, okay, must have effect. This is the right way. But since we do not have any answer like this there, so if you solve it the other way without including these mole ratios, I think we should get an answer. Okay, so if we have that, we just say delta H, okay, will be equals to, for the formation, will be equals to delta H for product minus delta H for reactant. So every other thing remains the same. So this will be minus 3. That will be, okay, delta H for CO2, that's the product, minus delta H for CO plus delta H for what? For oxygen. So this will be negative 393 minus, this will just be minus 110.4. Then we have plus, this is still what? 0. So we have this to be minus 393, minus times minus is plus 110.4. So by the time you subtract that, you'll be having negative 393 minus 110.4. That will be 10 minus 4 is 6. Then we have 2 left here. Then this 9 minus 1, yes, that's 8. 3 minus 1. So we have 282.6. Yes, 282.6 kilojoules per mole. So this, of course, is one of the options that we have there. So we must choose an answer. Okay, that is what it is. So, but like I said earlier on, to solve this question, this is the right way to solve it, because this number of moles we have effect there. But if we solve it without this, maybe the person that came up with the marking scheme for that particular exam couldn't, remember to include those two there, then this answer was arrived. But we must choose an answer all the way, because this is far apart from where? From the option that we have 503. 503 and 565 are not too close from there. So this one happens to be. So based on what we have solved now, my submission is that I'm going to go for this, since this is one of the answers that we have there, negative 282.6, and not this. So whatever your own submission is, please feel free to share with us on the comment section, and then you can explain. Let's move on to the screen so that we can see what we have there. Okay, like I was saying, okay, this is the closest. We have minus 503. If you solve it the right way, you should, by including the number of moles, multiply the number of moles by the what? The enthalpy change. Okay, but we had minus 565.2, which is not any of these options. So, but if you solve it without the number of moles, we have negative 282.6 kilojoules. So my submission is, I'm going to go for what? Option B, minus 282.6 kilojoules. Question number 27. Which of the following hydrogen halides has the highest entropy value? Hydrogen halides. That means hydrogen has combined with what? The halogens, okay? And then you know that as you move down the group in the halides, we discover that what? Atomic number what? Increases. Now, when we talk about entropy, entropy has to do with the level of disorderliness, okay, in the system. The level of the degree of disorderliness, or measure of disorderliness or randomness, okay, the molecules of that particular system. So generally, gases that have higher atomic weight, so as atomic weight increases, okay, what happens? We discover that what? The entropy, the level of disorderliness will also what? Will also increase. Okay, it will also what? Increase. If we look at option A, hydrogen fluoride, let's take each of these, the halogens, okay, because hydrogen is common for them. Fluorine has atomic weight of 19, okay. Chlorine has 35.5. Bromine has 80. Then iodine has 127, 128, but so you see that what happens is increasing. And we said that the higher the atomic weight, what happens, the higher the entropy value. The question says we should find the highest entropy value. So this we have the least, followed by this, and then this will have the highest. So the highest is this. So the correct answer is option D, hydrogen iodide. Question number 28. In the endothermic reaction above, more product formation will be favored by what? Okay, more product formation. Okay, so we can look at, we were told already that it's endothermic reaction, but usually if we want to look at endothermic reaction, we should consider the delta H, that's the enthalpy change, if it is negative or positive, but already they've told us that it is endothermic reaction. Okay, so but for me, to make it easier, this is gaseous. This is also what? Gaseous. Gaseous, gaseous. So, in terms of pressure, we'll be considering what? Gaseous substances. Because both of them are gaseous, so we can actually consider the effect of pressure in this system, okay? In equilibrium. Now, how many moles of the reactant do we have? We have just 1 mole here. So, this is 1 mole here. And then for the product is what? 2 moles, okay? And what does Le Chatelier's principle say? It says that the part, either the reactant, between the reactant and the product, the part of them that actually has, if it is the reactant of the product, the one that has the lesser value for the total number of moles will be favored by increase in pressure. I'm going to say that again. If you increase the pressure, okay, of the in the system that is already in equilibrium, the gaseous substances, the total number of moles of the gaseous substances on both sides, okay, the one that has the least or the lesser number of moles will be favored if you increase the pressure. Alternatively, it means that conversely, if you decrease the pressure, the side that has more number of moles will be what? Favored. A decrease in pressure. So the question is saying, in this reaction now, more product formation will be favored by what? Option A says a constant volume. If the volume of this is constant, okay, you are not going to be having more of this here because it says a constant volume. A constant volume is meaning the volume of this is constant, then this is also constant. It is not specified if it is the volume of the reactant that is constant or this. So this will not have effect in favoring this. Okay. Option B says an increase in pressure. Increase in pressure. If you increase the pressure, what happens? Like I said, if you have the side that has lesser number of moles, will be favored by increase in what? In pressure. So it's saying an increase in pressure. If you increase the pressure, this side has less number of moles. So which means this side will be what? Will be favored. But the question is saying, what will happen for this side to be favored? So if you increase the pressure, more of this N2O4 will be produced, which is not our aim. Question, so this is also not correct. Option C says a decrease in pressure. If you decrease the pressure, remember, according to the charter, the side that has higher number of moles or more number of moles will be what? Will be favored. So if you look at this, this is lesser, this is higher. So this side has more number of moles, okay, than this. So if you decrease the pressure, more of this formation will be what? Will be favored. And which is what the question says. More product formation, because this is the product. So to have more of this product formed, we just need to what? Decrease the pressure, and then more of this will be formed, will be produced eventually. So which means option C is actually correct. Okay, so option D says a decrease. So among these options now, the correct answer is option C, a decrease in pressure. On to question number 29. Which of the following shows little or no net reaction when the volume of the system is decreased? If you decrease the volume of the system, what happens? Is there an effect in the what? In the system. So let's look at option A. It says we have hydrogen reacting with iodine, okay, gas. We have 2 moles of this. Then we have this. Let's look at the number of moles. We have 1 mole here. We have 1 mole here. So 1 plus 1, we have 2 moles, okay, on the left hand side, and then we have 2 moles on the right hand side. Okay, there are different ways of solving this, okay, but let's look for the easiest way. So on this left hand side for option B, we have 2 moles here. And then on this side, we have what? 1 mole. Okay. On this side, option C, we have 1 mole here. Okay. 1 mole here. On this side, we have 1 mole, 1 mole. That is 2 moles. Okay. Then on this side we have 2 moles here, and on this side we have what? 3 moles on this side. Okay, so if you look at all of the options now, the only option that has equal number, because it's saying that which one will show little or no net reaction at all. And remember that according to Boyle's law, okay, Boyle's law states that the volume of a given mass of gas is inversely proportional to what? To the pressure, provided temperature is equal. So which means as volume is increasing, pressure will what? Will decrease. Okay, so which means if pressure increases, volume what? Will decrease. So vice versa. So we are looking at the relationship now between volume and pressure. If you look at this, we know that which one now? This one, 2 moles here, 1 mole here. So which means by default, if it is pressure, an increase in pressure will favor this side that has lesser number of moles. Look at this also, an increase will favor this side that has less number of moles. This side will be favored. But you discover that we have variation in the what? Number of moles. But in only A, we have 2 moles on the left hand side and 2 moles on the side. So once this happens, pressure has no effect, okay, actually on this. So vice versa, the same thing happens when we're talking about the volume of the system. So because we have 2 moles on the left hand side, 2 moles of this, considering the number of moles that we have here, a change in the volume of the system, if it is decreased, what happens? There will be little or no reaction at all in this. So because of that, option A is the correct answer. Question number 30. The allotrope of carbon used in the decolorization of sugar is what? Well, generally we know that we have about 3 different allotropes of carbon, but there are 2 that are commonly mentioned. We talk about graphite, we talk about diamond, okay? The third one is the amorphous carbon, okay? That's the one that is, and usually if you look at all the options we have here, it says the one that is used in decolorization of sugar. Option A says graphite. Don't get tempted because you know this one is an allotrope of carbon that we know. So I will just pick this. This is not used in decolorization of sugar. What this graphite is used for actually is just, you know, it is used as lubricant, lubricating oil in manufacturing, because it can also conduct electricity and so on and so forth. So option B says soot. Soot is not an allotrope of carbon. Okay, soot is just what you get from when you burn your charcoal or your wood. Okay, and then you have the ashes, you have those black substances like the ashes that settles to become what? Like dust. Okay, that's the soot. So that's not an allotrope of carbon. C says charcoal. Charcoal, yes, can be an allotrope of carbon, because don't forget we have charcoal of different types. We have the animal charcoal, we have the wood charcoal. Okay, yes, we have the activated charcoal. They are all different types of charcoal, but all of those charcoal, because they have you know, a porous surface. Okay, their surface is porous such that it can adsorb. When we say adsorb is not absorption. Adsorption has to do with surface. Okay, on the surface of it can retain. Okay, the color that is what? That is from that. Take the moisture that is present in that sugar and then take it. That's why you discover that activated charcoal is also used in treatment of water. Okay, to get a pure water that is colored, can be decolorized by using what? Activated what? Charcoal or activated carbon. Okay, that is an allotrope of carbon. Okay, so whether it is wood, whether it's activated charcoal, whether it is animal charcoal, they are all used in what? In decolorization of what? Of sugar. Okay, which is an allotrope of carbon. Then the last one is what? Lamb-black. So among these options now, the correct answer is option C, charcoal. On to question number 31. Which of the following gases can be collected by the method of downward delivery? Okay, you know, we have downward delivery, we have upward delivery. Upward delivery is a method of gas collection, okay, gases, okay, that are less denser than air. When you compare, that means air is heavier than them. Okay, so because air is heavier than them, in a column or in a container, you can have air downward, then while you have them, they are just above it. So those kind of gases, you can what? You can collect them by what? Upward delivery. Okay, so that air can be underneath. But if we have gases that are denser, that are more denser than air, what happens? We take them by what? Downward delivery. So which means air will be up and then the gas will be what? Will be down. So you can take it easily by what? Downward delivery. That's how you can collect that gas from what? From air. Okay, so in that case, if you look at these options that we have here, option A, which is chlorine, happens to be the only gas here. Oxygen is actually less denser than air. Okay, ammonia the same, and hydrogen, but chlorine is the one that is denser than what? Than air. So because it is denser than air, so it can be collected by what? Downward delivery. So based on that, the correct answer is option A, chlorine. Let's move on to question number 32. When steam is passed over red hot carbon, when we talk about steam, we are talking about H2O, that's your water, but in gaseous state. Okay, when steam is passed over red hot carbon, the substances produced are what? As a chemist, you can actually write that chemical equation. Let's see. Carbon, of course, carbon is your C. We have that passed over steam. Okay, that is your H2O, gaseous, to show that this is solid, to show that this is what? It is steam. Okay, by the time you react to that, we are going to have this oxygen will move. We have CO plus we have H2. They are together. It's a mixture, so they are not separated from the other. The oxygen is there, and this is what we call water gas. Okay, that's your water gas, or call it synthesis gas. It becomes synthesis gas if we have 3 moles of hydrogen, but it's CO and that. So water gas is formed, and it is a formation. It is what comprises of what? CO and what? H2. So carbon monoxide, CO plus what? H2. That is your water gas. This is what is going to be formed if steam is passed over red hot what? Carbon. Okay, we form water gas. Let's look at the options. We have option A says we have hydrogen and triisocarbonate 4 acid. No. Option B says hydrogen, oxygen, and carbon 4 oxide. Of course, we have oxygen, we have carbon, we have hydrogen. Yes, but it is not they are not separated. This is carbon monoxide or carbon 2 oxide. This is hydrogen. Option C says hydrogen and carbon 2 oxide. Hydrogen and carbon 2 oxide. Yes, option C is correct. Let's look at D. Hydrogen and carbon 4 oxide. If it's carbon 4 oxide, it will be CO2. Okay, and H2, but it is CO plus H2. So among these options, the correct answer is option C, hydrogen and carbon 2 oxide. Question number 33. Sulfur 4 oxide, that's your SO2, bleaches by what? Yes, SO2 can act as a bleaching agent. Okay, so sulfur 4 oxide bleaches by reduction. When we talk about reduction, of course, there are different definitions of reduction. Reduction is gain of electrons, right? RIG, gain of electrons. Reduction is removal of oxygen. Reduction is addition of hydrogen, okay? In this case now, because oxygen that is present, okay, in that fabric that needs to be bleached on the surface actually is there. So sulfur 4 oxide bleaches by reduction from SO2, okay, to become what? Sulfur, and then the oxygen is actually removed. So removal of oxygen is what? Is reduction. So it is not by oxidation, it's not by hydration, it's not by adsorption. Yes, adsorption has to do with what? Fixing on what? On the surface of the fabric, okay, but it is not by that way that it removes it bleaches. It is what? It removes oxygen from the fabric, from that stain that is there. It is by removing oxygen, and it is what? It is reduction of sulfur 4 oxide because there's removal of oxygen. And removal of oxygen is what? Is reduction. So that is what this. Though that type of bleaching is temporary, it's not going to last long, because once the fabric gets in contact with air, it can reoxidize again and then come back to become what? Colorized. So that type of bleaching is not. So if you want a permanent bleaching, we recommend that you use what? Chlorine. Chlorine will react with water to form what? To form a nascent oxygen. Okay, oxygen molecule, just oxygen mode like that. And then once it forms that, that will be able to what? To remove whatever state that is there, and that will remain what? Permanent. So for the sake of this question, sulfur 4 oxide bleaches by reduction. The correct answer is option A. Now let's move on to question number 34. Carbon is tetravalent because what? When we talk about tetravalency has to do with the ability of carbon, okay, to form 4 bonds. Okay, you know that carbon actually has 4 bonds. Okay, it's in group 4. It has a valency of 4. Okay, so it has a tendency to what? It has a special characteristic of forming 4. So whether it is forming bonds with alkane, with alkane, alkyne, the bonds of carbon must always be what? Be 4. Okay, so now you can explain or understand this tetravalent ability of carbon easily by looking at the what? The sp3 hybridization. Okay, sp3 hybridization has to do with a formation, a bond formation, where we have one s orbital, okay, reacting or combining with what? 3p orbital. That's why we have sp3 hybridization, and then each of the bonds are actually what's equal where you have them. Like you can have it in methane, CH4. Okay, that kind of bonding, sp3 formation is bond. So you can explain that more. Let's look at the options we have. Option A says the electrons in both the 2s and 2p orbitals are equivalent. Yes, even though they are, but that is not what is responsible for the tetravalency of what? Carbon. Yes, it has to do with the orbitals, okay? The 2s and 2p orbital, but it's not because they are equal. That is not the reason why we have carbon being tetravalent, okay? Ability to form 4 bonds. Option B says the electrons in all the orbitals of carbon are equivalent. The electrons in all the orbitals of carbon are equivalent. I hope you understand that. Okay, carbon has 6. Okay, that is 6. Yes, carbon 6. So which means we have 1s2, 2s2, 2p2. Okay, so all the what? The electrons are equivalent, but that is not the reason for carbon being tetravalent. Yes, we have 2, 2, 2 here, but this reason for it is not. Let's move on to the next option. Option C says the 2s and 2b atomic orbitals hybridize. Remember what I said? The tetravalency of what? Of carbon is based on what? The sp3 what? Hybridization. If you look at the hybridization, is what is responsible for its ability for it to form 4 bonds. Okay, it's as a result of what? The hybridization that it undergoes. So we have the 2s and the 2p atomic orbitals hybridizing. Like we have sp2, sp3, and so on and so forth. So because of this, carbon is able to form tetravalent bonds of equal bonds, okay, between the atoms that surround the carbon atom. So option C is correct. Let's look at option D. All the atomic orbitals of carbon hybridize. Okay, all the atomic orbitals of carbon hybridize. That's not the reason for having tetravalency of carbon. The reason why we have tetravalency of carbon, or carbon being a tetravalent element, is because of the what? Hybridization between the what? The s orbital and the p orbital. In this case now, the 2s and the 2p orbital. So based on that analysis, the correct answer is option C. The 2s and 2p atomic orbitals hybridize. Do you know you can take practice questions on our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool mobile app on your Androids and the Myschool software on your laptops and computers. Please go ahead and start practicing. Now let's move on to question number 35. Aluminum hydroxide is used in the dyeing industry as a what? In the dyeing industry, you know, we have the dye, we have the salts, we have the mordants, okay, dispersants, we have the salt, we have the dye in mordant. All of this one have roles that they play in dyeing of fabrics or clothes in the textile industries. Okay, salts. We are looking at aluminum hydroxide, even though it is a salt, but the function with which it performs, the function that it performs in this particular, you know, dyeing industry process, it is not acting as a salt. Because what do salts do? Salts just act as fixating substances. Okay, they can fix, they allow the dye that is cast or that is put on it to get fixed or on the fabric. We have dye, of course, dye, so it is not salt, it's not acting as a salt. Salt is to help, you know, make the dye, okay, when you impart it on this thing, to fix on the fabric, okay, but not for this. So the option B says dye. Dye, usually we know what it does is to impact the color, okay, the fastness, the color fastness, but the substance, okay, that ensure that the dye that is imparted actually has a color fastness. When we say color fastness, we are talking about forming a bond, okay, between the dye and the fabric upon which you are putting the dye is actually what we call the mordant, and that is what the aluminum hydroxide is used for in dyeing it. So aluminum hydroxide is used as a mordant Mordants are substances, of course, they are chemical substances, okay, that actually, they are salts also, okay, that actually help in what? In imparting the color fastness, okay, of that particular dye that is put there. It forms a bond, it forms a complex, yes, that's the word, forms a complex between the dye and then the fabric that we have there, and then once you form that, it's able to make the color of the dye to be impacted and then to stay and have a lasting effect on the fabric. That is what the mordant actually does. The function with the salt actually looks alike, but there's a little difference in them. So the aluminum hydroxide is used in the dyeing industry as a mordant, not as a salt. And then we have dispersant. Dispersant is when you disperse it, okay, how it spreads around, how it's absorbed on the surface of the fabric. That's not the function of the aluminum oxide. So the aluminum oxide is used in the dyeing industry as a mordant. So based on that, the correct answer is option C. I hope you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Now let's move on to question number 36. Alloys are best prepared by what? When we talk about alloys are substances that are formed, okay, when you have two or more metals combined together, okay, to form a desired characteristics or properties that you actually desire, okay. Alloys are formed. We can also have alloys being formed by combining metals with non-metals, okay, to form alloys, okay. The process in which we can do that is what the question is. So you say alloys are best prepared by what? When we talk about option A, electroplating. Electroplating will just require that what? A thin layer is just put on the surface of the other metal, okay. So that will just get, so it's just like it's a kind of coating. So when we are looking at corrosion, okay, trying to avoid or prevent corrosion, electroplating can come in place, but certainly not in the preparation of alloys. So option A is eliminated. Option B, we talk about arc welding. When we talk about welding, we have to join two metals together, okay. We have maybe an electrode, or you have a kind of flame to join two metals together. If you join, imagine you getting iron and then you get copper, you get another copper, trying to melt them together. So that's not going to form alloy, okay, because you just have distinctly the two or more metals or substances you are combining together. You have them separated even though they are joined together, okay. That's not alloy. Option B, so that is also what it means. Option C says reducing and mixture of their metallic oxide. If you reduce or you subject the metallic oxide to reduction, okay, you are not going to have a full-fledged alloy being prepared, okay. So that is also what eliminated. The option D says cooling a molten mixture of the metals. Cooling a molten mixture, yeah, I think that is the best way. In fact, let me explain what happens. To get alloys prepared, you get the metals you want to melt together, you want to join together, subject them to a high heat. So when you subject them to high heat, they melt. So once they melt, the two or more metals, or the metals and non-metals that you desire to join together to form the alloy, will mix together. Once they are melted. So once they are melted, the liquid form now is now what you now get, and then already you would have prepared your mold, okay, the mold in which you want to use in making to form that particular the substance you want to form the alloy into. So once you have melted the metals together, then you now, don't forget, it is in molten form now. It is like it is in liquid. It's not liquid, I would say liquid, it's in molten form, so it is not solid. So it can pour. So you can now pour it on that mold. Once you pour it on the mold, so it now assumes the shape of the of the the structure you want it to take in the mold. So once it gets cooled, it becomes solidified, then it can now become, that is the process that is used in making all those spanner, that are used in the mechanic workshop, in the engineering, and some of those equipment, okay. Some of them are from alloys. They melt them, they cool them, it solidifies, and then it comes into that. So that's how alloys are formed. So option D says cooling a molten mixture of the metals. That is the way in which alloys are prepared. So the correct answer is option D. Now let's move on to question number 37. Transition metals possess variable oxidation states. Why? Because they have what? We know that transition metals are metals that are formed because they have partially filled d orbitals. Partially filled d orbitals. What are filled there? We have electrons that are filled in the d orbitals, partially filled. Okay, that is the reason zinc that has atomic number of 30 is mostly not considered to be a transition metal, okay, based on that fact, because it has completely filled d orbitals. Okay, transition metals are supposed to have partially filled d orbitals, electrons filled in the d orbitals. That's what makes them transition metal. Of course, that's what is required, that is responsible for the characteristics that they impact. Apart from other metals, the ability to form color, yes, we say color formation. They form complex ions. Okay, then they have variable oxidation state. They are magnetic, paramagnetic in nature as well, and they can be used as catalysts. So all those features are characteristics of what transition metals, and as a result of what, having the d electrons in their d orbitals. Let's look at the options there. Option A says electrons in the d orbitals. Of course, that is it. So let's look at option B, says electron in the s orbitals. That does not impact that. If you know what transition metals are, they are able to have what, partially filled d orbitals, electrons in their d orbital, which is option A. Option C says a variable number of electrons in the p orbitals, not the p orbitals. The option D says partially filled p orbitals. That's a little bit tricky. Partially filled d orbitals. Okay, that would have been not the p orbitals. It is the d orbital that partially. So already option A says electrons in the what, d orbitals. So based on that, the correct answer is option A. On to question number 38. Sodium metal is always kept under oil because it what? Generally, there are two things, or let me say three gases usually, or three things that actually affect or that react to sodium metal. We have oxygen, we have water, we could have carbon dioxide also. Okay, but among those three, the two major things that are responsible for reaction of sodium metal is with oxygen and water. Oxygen and water are the two things that will react with what, sodium metal. In fact, it's vigorous. It can even cause fire. It can cause flame. Okay, once it is what. So that is the reason sodium metal is always kept in paraffin oil, not just oil. In paraffin oil, if you keep it on the paraffin oil, it will shield it. Okay, the surface, so that it does not come in contact with what, with air and water. With air and water. So if based on that, if you understand what happens, what causes the reaction of sodium metal, okay, why it is being kept under oil, then you know what to choose. Option A says readily react with water. Yes, it readily reacts with water, but only water will not cause that reaction, chemical reaction, vigorous reaction, what, to take place. It requires oxygen. So option A has only water, does not have oxygen, so we cannot pick option A. Option B says it is reduced by atmospheric nitrogen. Of course, we know that nitrogen does not support burning, so nitrogen is not one of them. So option B is eliminated. Option C says react vigorously on exposure to air. Remember what I said earlier on, that we have oxygen and we have water. Those two factors are responsible for the reaction of sodium metal. That is why vigorous reaction, that is why it is kept under paraffin. But if you look at oil, air, we said is a mixture of gas. We have water vapor present in there. We have oxygen present in there. We have nitrogen and other gases present in there, okay, in air. So if you expose it to air, it can easily cause what, a vigorous reaction once it is exposed to air. So oxygen and water are present in air. Look at option D. Option D says react with oxygen, yes, and what, carbon dioxide. Yes, with carbon dioxide, but the reaction is not vigorous, not much with it. Like I said, the two major factors are what, oxygen and water. So option D, if option D had react with oxygen and water, yes, it would have been a perfect option to go for, but we don't have that. We have oxygen and carbon dioxide, so we cannot go for option D. Rather, we suggest that you go for option C, which say react vigorously on exposure to air. The reason being that in air we have oxygen, in air we have water vapor in air that are what, responsible for reaction with that, to cause a vigorous reaction with that. So based on that, my submission is that option C is the correct answer. If you choose, if you feel you want to go for option D and you have your reasons, okay, scientific proof, well, fine, you can share with us on the comment section and the reason why you feel that is correct, okay? But based on the analysis, okay, the subjection is that what? The objection is what? Submission is that what? It reacts. Sodium metal is always kept under oil, paraffin oil, because it reacts vigorously on exposure to us. So the correct answer is option C. Question number 39. Oxyacetylene flame is used for iron welding because it what? Oxyacetylene flame is a mixture of oxygen, okay, flame, oxygen flame, and then acetylene flame or ethylene, acetylene or ethylene flame, okay. Both flames, when combined together, produce high heat, okay, not just high heat. In fact, the flame that the temperature is very high temperature heat that can melt ions together, okay. You can imagine oxyacetylene flame having a temperature of about 3100 degrees Celsius. Of course, that kind of temperature can melt, in fact, can melt steel. Steel is just about 1500 degrees Celsius or thereabout, okay. So 1500, and then you have a flame that is around 3000, over 3100 degrees Celsius. Of course, it will melt steel. So it is used for iron welding because it, what option A says, makes the iron metals solidify very quickly. Solidify, no, that is not easy to solidify. Then it's not going to be used as that, because we are talking about welding. Iron welding has to be joining together, okay, two metals together, two ions together to melt it. So it is not because it's going to solidify very quickly. Option B says combines with oxygen to give a pop sound. The pop sound has nothing to do with what? The holding together, because we're talking about iron welding. That means the ions are held together, okay? It's metal. The ionic metals are held together. So the pop sound does not have anything to do with that. Option C says evolves a lot of heat when burnt. Of course, like I said, we have high temperature from oxyacetylene. It produces acetylene as high as 3100 degrees Celsius. So that temperature is high. I'm not sure any human being can survive being in that type of flame, okay? So it is so hot, so it produces a lot of heat, okay, when it is burnt. So option C is correct. Let's look at option D. Dissociates to produce carbon dioxide and oxygen. Of course, oxyacetylene does not have that. That is not what it is. Of course, even if you produce, even if you see it, this being flame being used, what we have is carbide, okay, like we call it carbide, yes, calcium carbide. That's what you have. Calcium carbide is produced. Eventually, those white substances, when you have them, when you go to maybe these welders, those panel beaters, you see those white substances like chalk, okay? Those are your carbide, okay? They are from what? Oxyacetylene flame that we have there. So, among these options now, oxyacetylene flame is used for iron welding because it evolves a lot of heat when burnt. The correct answer is option C. Let's move on to question number 40. The alkyl group can be represented by the general formula alkyl. If you look at that alkyl, okay, it's actually gotten from alkane. Okay, and you know alkane is what? Cn as the general formula, CnH2n plus 2. So for the alkyl now, the ANE is removed and then we have YL to replace that. So which means something must be removed from this. So what is removed is what? Hydrogen. So one hydrogen will be removed from the alkane family to form alkyl. Okay, one hydrogen. So if you are removing one hydrogen, so which means this two that is here now, this man here will reduce by one. That's why it is what? Alkyl. So it becomes CnH2n plus 1. So this makes it becomes alkyl. So in other words, that's why the name. If you see methane for alkane, okay, which is what? CH4. By the time you remove one hydrogen, it becomes CH3. So it will no longer be called methane. This will be called what? Methyl. Okay, because of it's an alkyl. The same thing happens if you have ethane, which is C2H6. Okay. Remember, to make it alkyl, you remove one hydrogen from here, so it becomes C2H5. So it becomes like a substituent that is adding to the what? Carbon chain. So it will not, instead of being ethane, it becomes ethyl. Okay, so it becomes what? A substituent group that is added to that. So you just remove out one hydrogen. So this is general formula CnH2n plus 1. Let's look at the options we have. Option A says CnH2n plus 1? Yes. CnH2n plus 2, this is what? Alkene. 2NH2n plus 2, this is what? This is your what? Alkane family, which is this. This is CnH2n minus 2, this is your what? Alkyne, okay? Family, which is the, but we are talking of what? Alkyl group. So it should be CnH2n plus 1, okay? Which is removal of one hydrogen from the alkane. So the correct answer is option A. Let's move on to question number 41. An isomer of C5H12 is what? What is an isomer? An isomer comprises of two or more compounds, okay, that have the same molecular formula but different structural formula. When we talk about molecular formula, number of atoms, okay, of the carbon and hydrogen, as the case may be, are the same, are equal, but the way they are drawn structurally are actually different. So which one is an isomer of the? Let's move to the board and let's just quickly draw out what the possible isomers of C5H12, what it could be. So we have C5H12. First, you must draw to what? The straight chain of that. So we have 5 carbon atoms. 1, 2, 3, 4, 5. Then you fill them with what? With hydrogen. Okay? Hydrogen here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So which means we have C5H12. Of course, this is your what? That is your pentane. Okay? So we can draw it again. In drawing this, we'll move. You can just displace one C non-carbon atom. So instead of having 5, to have a straight, a branch chain now. So since we have 5, let's reduce it to 4. 1, 2, 3, 4. Okay, then the 5th carbon can be on this, not on this. If you put it on this, it will still be the straight chain. So we'll put the 5th carbon here, and then we have 1, 2, 3, 4. Remember, all the carbon atom must have 4 bonds. 1, 2, 3, 4. 1, 2 here, 1 here, 1, 2, and 3. So let's count together. How many carbon atoms do we have? 1, 2, 3, 4. That's plus this 5. That's C5. Then how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see that together with this? So pentane has evolved. What is the impact name for this? Okay, that is actually okay, this is carbon 1, carbon 2, carbon 3, carbon 4. Okay, so the straight chain is actually what? Butane, because we have 4 carbon atoms. Then we have a what? A substituent group on what carbon atom? On carbon number 2. So that is 2. What is the first? CH3. That is what? Meth. 2-methyl butane. So that is 2-methyl butane. So this is one of the isomers of C5H12. Let's see if we have the answer in this. 2-methyl butane. Yes, we have an answer there. So let's not waste much time. So let's move on to the board. We don't have pentane. Pentane here. But we have butane. Butane is wrong. We have 2-methyl butane. Let's move on to the screen and see 2-methyl butane. We have 2-methyl butane here for option B. So the correct answer is option B. We are moving on now to question number 42. A characteristic of the alkane family is what? When we talk about the alkane family, don't forget the alkane family are the saturated hydrocarbons, okay? While alkene and alkyne are the unsaturated hydrocarbon. The reason being that they have the double bond carbon-carbon atom and triple bond carbon-carbon, as in the case of alkyne, okay? So the ones that are saturated are just the alkanes that have a single bond between the carbon-carbon atom. So all alkanes usually have a characteristics of the what? The reaction, which is what? Substitution reaction. Because between the carbon-carbon, okay, there's no bond that is going to break open. If you look at this one, for instance now, for this one to have anything coming in here, maybe reacting with any substance at all, this bond will be what? Will be broken up. But for this guy here, all the carbon atom, the bonds here are completely what? Are just spread out. So there's nothing you are opening, you are not opening any bond here. So for any substance to come in here, it is what? You know, we have hydrogen here, hydrogen here, hydrogen here, and so on. So let's say, for instance, chlorine molecule is coming in here to react with this. So what will happen is what? You cannot say that you are going to have chlorine attaching here, No. What will happen is that what? This chlorine molecule will come and form off get substituted, we displace any of this hydrogen here. If it is the 2 that want to form, this hydrogen will be off, Cl comes here, this other chlorine will come in here. So 2 hydrogen that are removed now, we have H2 eventually that is here. So there is a substitution of the hydrogen with what? With chlorine. So substitution reaction, that is the reason substitution reaction is peculiar to alkane family, which are what? Saturated hydrocarbons. Saturated hydrocarbons will undergo substitution reaction. If you look at option A says addition reaction. The unsaturated hydrocarbons will undergo that. The alkene and alkyne. Elimination reaction, interaction reaction, that one is specific to between acids and base, can undergo that. So substitution reaction is usually for what? The alkane family. So the correct answer is option C. Question 43. Which of these reagents can confirm the presence of a triple bond? Triple bond, that means carbon-carbon triple bond. That's the alkyne. Okay, how do you distinguish an alkene from an alkyne, even though both of them are unsaturated hydrocarbon? How do you differentiate them? Option A says boiling water. Now, before we look at the options, this reaction is a confirmatory test for alkyne. Okay, now there are reagents that we can use. Bromine water and Bayer's reagent. I'll just put that here. Bromine water and Bayer's, Bayer's reagents are actually used in testing for the presence of triple bond. We also use the third one, ammoniacal cuprous chloride. Ammoniacal cuprous chloride. That one has a formula this way. Ammoniacal. Okay, we have that. We have NH3. We have 2. We have Cu. We have ClOH here. Then we have Cu. Of course, the compound. The formula looks more of that. We have that. And then we have that. Ammoniacal. You can check up for the formula anyway for ammoniacal cuprous liquid. So if you bring this one into a substance and then we have a red precipitate form, the presence of red precipitation is showing that it is what? It is an alkyne that is present there. So we can test for the presence of what? Of triple bond. So you can use ammoniacal cuprous chloride, which is this, or you can use bromine water, or you can use Bayer's reagent. Any of this one will just what? We just make the color of the reagent what? To disappear. If you bring it, if it is an alkyne, okay? If you use bromine water, the color of the reagent will disappear. If it is Bayer's reagent is another name that is referred to as alkaline, popularly known as alkaline KMNO4, okay? Alkaline KMNO4 is your Bayer's reagent, bromine water, or cuprous, ammoniacal cuprous chloride. So any of this can work. If you use this, it gives you a red precipitate. If it is not red precipitate that is formed, that means it is an alkene. But if red precipitate is formed, it means it is an alkyne. If you use Bayer's reagent, bromine water, most of these two will decolorize. The color will disappear. So let's look at the options that we have now. Which of these reagents can confirm the presence of a triple bond? Option A says bromine water. That's correct. So let's keep that here first. Let's look. Option B says acidified KMNO4. No. If it were alkaline KMNO4, they are not the same. Alkaline KMNO4 is your Bayer's reagent. I already analyzed that. So acidified KMNO4 will not. But if it were alkaline KMNO4, that is your Bayer's reagent, that would have been correct. So which means this is also wrong. Option C says copper 1 chloride. Please don't get confused. Copper 1 chloride is not the same thing as ammoniacal cuprous chloride. Okay, you can see it here. I intentionally wrote out this compound. You can see this and copper 1 chloride are not the same. Okay, so if you have it here, it's not the same thing as this. So ammoniacal cuprous chloride is what will also react. So this is not correct. Then option D says bromine gas. Bromine gas and bromine water are not the same. Okay, so that is not. It was just put there intentionally to check if you actually know what is right. Okay, so the correct answer here is the use of bromine. Of course, like I said, you can use any of this, but that's why we don't have all of this option in here. So the correct answer is bromine water. Option A is the correct answer. On to question number 44. Vulcanization involves the removal of what? Yes, you know, vulcanization usually will bring in sulfur, okay, to improve the rubber strength, the strength of the rubber, okay, in the vulcanization in the rubber industry, okay, like all the tires, the tubes of tires and all that. That's why you have the vulcanizers also already working on that. So what is done is that there's always a removal of, we have double bonds that are linked up together with those monomers. So if you want to vulcanize, then that means the double bond will be removed. The double bond will be removed. We have option A says a monomer, not a monomer. Like I say, vulcanization involves what? We have the double bond be removed. We have single bond, it's not correct. Option D says a polymer. Polymer of what? No, it's not the polymer that's removed, it is the link, okay, the linkage between, okay, the polymer, okay, that we have. The polymer is what is formed eventually, which is your rubber, okay. So, but in the vulcanization, when we want to remove, we are talking about removing of the double bond. There's double bond between this monomer and this monomers that are linked together. So that double bond that is linking them together with the sulfur is what? That is what removed during vulcanization. So the correct answer is option C, the double bond. Do you have any question bothering your mind on all we have done so far? Please feel free to ask a question. All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to ask your question and solutions will be provided within the shortest period of time. Now let's move on to question number 45. We have CH3COOH. This is ethanoic acid, okay? Yes, giving us CH4 and then we have CO2 here, okay? All the gases form. This is methane and CO2. So the reaction above is what? Carboxylation, okay? If it would have been carboxylation, if there is addition of carbon dioxide, okay? Carbon dioxide or the alkanoic acid, okay? When you add any compound that comprises CO2, okay, or that has COH here, what happens? It becomes carboxylation, but we don't have that happening here because this one is just breaking down to what? To methane and CO2. Option B says decarboxylation. Yes, it can be. It should be decarboxylation. Decarboxylation reaction of alkanoic acid involves what? Removal of the functional group, the COOH group, okay? This COOH, if you remove it, okay, we call it carboxylation. Of course, this is the same thing as CO2H, okay? So carboxylation, that there is being removed. So that's why if you look at this reaction, we have CH, the hydrogen eventually adds up to this to become CH4. That's what we have there. Then we have COO left. COO is your what? CO2 that is there. So that is actually decarboxylation reaction. Yes, option B is correct. Option C says acidification. We are not acidifying it. This is acid itself. We are not adding acid to it, so it is not acidified. It's not acidification. So option C is eliminated. Option D says esterification. Esterification is a reaction that has to do with an alkanoic acid reacting with what? With an alkanol to provide or to produce what we call ethyl or what we call ester, okay? That is alkanoic reacting with alkanol to form alkanoate. So it's either you have alkanoate or you call it ester plus what? Plus water. So that is not the case here. We only have alkanoic, okay, acid here. We don't have a reacting with alkanol to form that. So it is option, not option D. So the correct answer is option B, decarboxylation. Do you have better steps on how we can solve this question or better explanation on all the questions we've solved so far? So please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the answer you wish to share with us. On to question number 46. C2H5OH, that is your ethanol, okay? We are going to process to form Y. If the above reaction takes place in the presence of concentrated H2SO4, okay, that is a dehydrating agent. H2SO4 is acting as a dehydrating agent here, okay, to dehydrate, through dehydration at 180 degrees Celsius. Y represents what? So dehydration of ethanol will always give us what? Ethene, okay, or ethylene, ethene, C2H4, okay. So that means the H2SO4, conc H2SO4 will remove the water presence that is there, okay, H2O molecule, and then if you remove one hydrogen from here, we have H4 left. Okay, that hydrogen combines with this OH to form water at this point. Okay, the water that has already been been removed. Okay, when water is removed, because we say it's acting as the H2SO4 is acting as a dehydrating agent. Okay, so it removes water, and then we have C2H4 left, and this is your what? This is your what? Ethene or ethylene. So option A says CH4, that is your methane. That is not correct. Option B says C2H5COOH. Okay, no, this is not correct. This is your propanoic acid. Okay, we have 3 carbon atoms. That is not correct. Option C says C2H4. Yes, that is our ethene. Yes, that is correct. Option D says CH3OCH3. That's methane. Okay, so that's not correct. So the correct answer is option C, C2H4. Let's move on to question number 47. Alkanol plus alkanoic acid gives ester and water, of course. We have a reversible reaction here. The forward reaction is referred to as esterification because it involves the what? The formation of ester. The backward reaction is referred to as hydrolysis. Okay? Hydrolysis. So which means that when alkanol reacts with alkanoic acid, that's the forward reaction, to form ester and water as the product, or alkanoate as the product and water, the process is called esterification. On the other hand, when ester reacts with water to form alkanol and alkanoic acid, that reaction is called hydrolysis. Okay, hydrolysis reaction has taken place there. Option A looks like what we just said, hydrolysis, the reversible, because the question says the reverse reaction above is known. So the forward reaction is esterification, alkanol reacts with this to form ester and that, but the reverse reaction is what? Hydrolysis. Option B says saponification. Saponification is the process of making soap. Okay, we talk about alcohol with fats and oil, or with fatty acids to produce what? Soap. Okay, it could be sodium hydroxide, which is a caustic soda, reacting with fatty acids to produce soap, and maybe glycerol. Okay, that is saponification. The process of making soap is what we call that. So it's a reaction between fats, okay, and oil, or oil reacting with what? Caustic soda. That's not what we have. Reacting with alkali. That's not what we have here. This is ester and water to give that. So option B is wrong. Option C says hydration. Addition of what? To hydrate something is to add water. So that is not correct. Also, option D says fermentation. Fermentation reaction is a reaction that has to do with the acting of microorganisms, okay, like your yeast, okay, on sugar. So to break down that glucose, to break down the sugar to form ethanol and what? Carbon dioxide is what we call fermentation. So this is not having any place to place. So among these options now, the reverse reaction above, which is this, is actually hydrolysis. So the correct answer is option A. Question 48. In the production of soap, concentrated through the process of saponification, okay? In the production of soap, concentrated sodium chloride solution is added to do what? Once the soap is produced, okay, it's done, and then you pour it. Of course, it's still in the molten form. You pour it into the mold of what you want to, the shape of the soap you want it to be, like all the soaps that we get, the bar soap, you know, and so on. If you want to take the shape of what you have is the mold. There's a mold, okay, when the caustic soda or when the alkaline, okay, solution has been what? Has been reacted with the oil, maybe fats or oil, it could be coconut oil, okay, it could be castor oil, depending on what type of soap you want to make, okay, and then you add up all the other ingredients. We talk about maybe the perfume that is added in soap making. So by the time it's all of those ones are produced, now we want the soap to precipitate out, to come out, okay, like to form. Once it forms, to come out and then reduce its level of what? Solubility in the solution. What happens? We had concentrated sodium chloride. So when you had concentrated sodium chloride into that soap that is formed, okay, it is just what make the, it's not going to be, it will make the soap that is in the solution what? To precipitate, to form, come out to sort out. Yeah, we call it sorting, to sort out and then come out. Once it comes out like that, then it becomes what? Very hard for it to begin to dissolve. Okay, we call that decrease. It will decrease the level of solubility of that particular soap. It's not going to increase, it's going to decrease the soap to what? From dissolving so fast. Okay, that's what we said, solubility. So that is the essence of adding concentrated sodium chloride solution during the production of soap. Option A says increase the solubility of soap. No. If it is going to increase the solubility of the soap, then there's no. Don't forget, this is what called sodium chloride solution. Of course, that's a brine solution. When you add it in, it will sort out. It will precipitate as if it will form out, so that it will not be soluble. Okay. Option B says decrease the solubility of the soap. Yes, that's correct. Option B says, C says saponify the soap, and option D says emulsify the soap. Those are grammars. Okay. So the major thing that happens is just that there's a decrease. It tries to this concentrated sodium chloride solution during the soap production is introduced in order to decrease the solubility of the soap. So the correct answer is option B. Now let's move on to question number 49. We have an experiment here, a diagram here. That is air coming in here, and then we have alkaline pyrogalol. That's the content we have in here. Okay, and then we have it. Okay, this moving here. Then we have a U-tube kind of a shape that we have here. Then inside of this we have an hydrous calcium chloride, and then here we have this coming out, and then we have X eventually. So the question says, in the experiment above, X is a mixture of nitrogen. This X here is a mixture of nitrogen, that's N2, carbon dioxide, CO2, and what? So there are three gases that are in this X. So the examiner wishes to know if you know what other gas that will be formed together to have this. Let's analyze this together. Now, first, air comes in here. When we have air coming in here, you remember or you recall that air is said to be mixture of gases. So in air, we said mixture of gases, right? So which means we have first, with the highest percentage, we have nitrogen is here, we have oxygen is here, we have CO2 is here inside the air, we have argon, okay, or let's just say rare gases. Rare gases are here, or inert gases, they are the same thing. And then we have impurities, okay, and so on and so forth. Okay, so then we have water also. Water vapor is here. All of these ones are gases that are present in air. Okay, now we're told that from the diagram, that's what we can infer. Let's analyze it. Air comes in here. So if air is coming in, all of these are all coming in with the air. So when it gets into this chamber here, this conical flask, we have alkaline pyrogalol. What does alkaline pyrogalol do? What it does is to react with oxygen and remove oxygen from the air. That is what it does. So once air comes in here, this man that is here, oxygen, will be knocked off. So which means as it comes in and comes in contact with alkaline pyrogalol, air comes in contact, oxygen is trapped off. So leaving us with nitrogen, carbon dioxide, rare gases, impurities, water vapor, and so on and so forth. So the remaining ones, we move into this place and then keep moving here. Come into this place and then come into this chamber. Once it comes in here, remember we said what we have is anhydrous calcium chloride. In this anhydrous calcium chloride, what do we have there? That is what we call drying agents. Yes, that's the word. Calcium chloride, anhydrous calcium chloride, that's the calcium chloride that has no water, is actually an example of drying agent. In fact, a strong drying agent. So what do drying agents do? They try to trap and remove moisture content or water vapor that is present in the substance and keep it dry and to keep it at a room temperature. So once this comes in here, this remaining one comes in here, the one that is attracted to this, what calcium chloride is looking for in the other components of air is what? Is water content. And then it sees water vapor here. And then so, oh, water vapor is here. Okay, come and stay with me. Then it traps water. So water vapor is also knocked off from there. So we have the remaining gases are what is going to come out as X. So now let's look at what we have here. Okay, impurities, let's take it out of impurity. Okay, so we have, what we have left is nitrogen, carbon dioxide, and rare gases. So these are the three things that will be formed in this what? In this X. Nitrogen, carbon dioxide, and what? Rare gases. Either you call it rare gases or we call it inert gases. Okay, any of those ones will pay. So I think that answers the question now. In the experiment above, X is a mixture of nitrogen, carbon dioxide, and what? Option A says water. Water is wrong because water has been removed here by anhydrous calcium chloride, so it is kept dry. Option B says impurities, where we are talking about gases, okay? Because this one is just a mixture of that. This gas, we have impurities, should also have been trapped out, okay, before we get to this point. So impurities is not going to be, so we can remove impurities. Okay, I think that the air has been purified already from impurities, that is C, okay? And then we have C here is the inert gas. Inert gases here we say are the rare gases also, so more likely option C. But let's look at option D, is oxygen. Oxygen already has been removed by what? Alkali pyrogalon. So among these options now, the correct answer is inert gas. Option C is the correct answer. Let's move on to question number 50. We have an hydrocarbon here. The hierarchical nomenclature of the compound above is what? Okay, so we want to name it. Let's see. We have CH3 here. We have CH3, C. Okay, let's see. The longest chain is what we want to consider now. First, the parent name. That's the longest chain. Let's count from here. This is 1, 2, 3, 4. That's 4. Okay, let's try another one. This is 1. Okay, the first one is 1, 2, 3, 4. Okay, then let's try this one. 1, 2, 3, 4, 5, 6. Okay, 6 should be the longest. If you count from here, 1, 2, 3, 4, 5. We could have also 1, 2, 3, 4, 5, 6. We could also have 1, 2, 3, 4, 5, 6. So whether you are going this way, or you are going this way, or you are going this way, the longest chain is 6. So let's just stick to one. The one that is 6. So let's take from here 1, 2, 3, 4, 5, 6. So that is this carbon atom here. That is hexane. That's the parent name, hexane. Okay, we don't have a double bond there, so it's hexane. So the next question is, do we have any functional group that is acting as the substituent? Acting as the substituent. Do we have, let's see, this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Yes, this is the straight chain. Any other chain or any other functional group that is attached, apart from hydrogen, that is attached to the carbon atom that is not on the one we name now, are actually functional group, can act as functional groups that act as a substituent group. Okay, so let's see now. We have apart from what? Hydrogen. Here we have one here. This is not hydrogen, this is CH3. So this is one substituent group. Let's look on. We have another one here. This is another what? Substituent group. Let's see, we don't have anyone again. So we have two substituent group at this point. Okay, and what are they? CH3, that is your what? Methyl. How about this? Methyl also. So we have two methyl, as some will call it, or you call it methyl, whichever pronunciation. So we have two methyl here. So on what carbon atoms are they? So we say the first one is on carbon 2, the second one is on carbon 3. So that is carbon 2 and carbon 3. So we have two methyl group on what position? Carbon 2 and carbon 2. So we are going to put those numbers first. Carbon 2, 3. So we have 2, 3. Then we have hyphen now. What are the names? The two of them are the same. That's why we are having 2, 3. Okay. If this were C2H5 as ethyl, and then this one is methyl. Ethyl comes alphabetically, so it would have been 3 ethyl, and then we have this one. This would have been ethyl. Okay, then we have this. This would have been option 2. So that would have been 3 ethyl, then 2 methyl. But 2 of them are methyl. So we have 2, 3. Because there are 2 methyl, so we have dimethyl hexane. So the name for this, the IUPAC nomenclature for this is 2,3-dimethyl hexane. 2,3-dimethyl hexane. Let's look at the option that fits into that. Option A says 2-ethyl pentane. Option B says 3,4-dimethyl pentane. It is 3,4 if you count from here. 1, 2, 3, 4. 5. It's not even 3, 4, it is 5. Okay, so which means that is, it's saying that 3 and 4. No, that is wrong. It is not correct. So that is off it. Option C says 2,3-dimethyl hexane. 2,3-dimethyl hexane. That's what we had already. So the option C is correct. Option D says 2-ethyl hexane. 2-ethyl hexane. That is not correct. We have 2,3-dimethyl hexane. So based on that, the correct answer is option C, 2,3-dimethyl hexane. I hope you enjoyed this content because I really did solving those questions. If you really do, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.